Today we're going to talk about refutation by parallel reasoning. Okay, so what's refutation by parallel reasoning? Let me start by giving a definition and then I'll give some examples. So first, to refute an argument by parallel reasoning is to show that the argument's form is not valid or strong. The form of the argument is bad. Now, one way to show that, a way that we've described over the past couple of weeks, is to show that the argument commits one of the fallacies that we've described. For instance, that it commits some kind of a slippery slope fallacy, or it's a fallacious dismisser, or fallacious amplifier, or commits a fallacy of equivocation. That's one way to show that an argument is a fallacy, that its form is not valid or strong, that its premises, whether true or not, don't support its conclusion. But sometimes an argument is a fallacy even though it doesn't fit into any of the categories of fallacy that we've described up until now. But you can still show it's a fallacy, and the way you show it's a fallacy then is to refute it by parallel reasoning. And the way you do that is by finding another argument that has exactly the same form as the first argument. Exactly the same form, but the other argument is clearly a fallacy. So if the second argument is clearly a fallacy, and it has the same form as the first argument, then the first argument must also be clearly a fallacy. Since whether an argument is a fallacy or not doesn't depend on the truth of its premises or the truth of its conclusion, whether an argument is a fallacy or not just depends on its form, on the relationship between the premises and the conclusion. So if you can find an argument with exactly the same form that's clearly a fallacy, that shows that the first argument is a fallacy. That's refutation by parallel reasoning. Now let me give you some examples. So consider this argument. Premise: if I had a higher salary, I could buy a bigger house. Conclusion: therefore, if everyone had a higher salary, everyone could buy a bigger house. Okay, now I've heard reasoning that resembles this kind of reasoning in the past. People think, well, if we can raise one person's wages and make them materially better off, then if we could raise everyone's wages, we could make everyone materially better off. Okay, but tempting as this kind of reasoning may be, it's fallacious. And in order to show that it's fallacious, let me refute it by parallel reasoning. Let me find another argument that has exactly the same form, but that's obviously a fallacy. So consider this example. This is a parallel argument. If one person stands up at a ball game, then she'll get a better view. I'd imagine that she's sitting in an audience of people, all of whom are seated. Right, so there are all these people seated and watching the ball game, and maybe the people sitting in front of her are blocking her view of the events in the stadium. So she decides to stand up so she can see over the heads of the people seated in front of her. So if she stands up, she'll get a better view. Conclusion: if everyone stands up at a ball game, then everyone will get a better view. Okay, well, that conclusion is not just obviously false, but it's clearly not supported by the true premise. In fact, this argument is a very clear example of an invalid argument because the premise is very plausibly true. In just about any ball game, when you have one person sitting down, if they stand up, they individually are going to get a better view. But the conclusion is certainly false. If everyone stands up, then that does not mean that everyone will get a better view. In fact, if everyone stands up, then there are going to be some people who end up getting a worse view. So, this is clearly an invalid argument. But if this argument is invalid, then this argument must also be invalid because they have the same form. And that shows that this first argument about salaries has got to be invalid. It's got to be invalid because it has exactly the same form as the second argument about standing up at a ball game. It has exactly the same form, and the second argument is obviously a fallacy because in most scenarios the premise would be true and the conclusion would be false. So if the second argument is invalid, the first argument must be as well. Okay, that's an example of refutation by parallel reasoning. Now let's consider another example so you get the idea. So consider this argument. Premise one: most people who start their own businesses, ignore statistics of failure, right? Because the statistics of failure for startup businesses are pretty bleak. Vast majority of startup businesses fail. They lose money, they go out of business, they go into bankruptcy. So most people who start businesses have to ignore all that, have to believe somehow, despite all the statistics of failure, that they are going to succeed. Premise 2, most people who ignore statistics of failure are stupid. Conclusion, therefore, most people who start businesses are stupid. Okay, now let me say immediately that I think this argument is a fallacy, and furthermore, that its conclusion is false. But how can we see that this argument is a fallacy? From most people who start businesses ignore statistics of failure, and most people who ignore statistics of failure are stupid, how can we see that it's fallacious to infer most people who start businesses are stupid? Well, to see how this argument is a fallacy, compare it to this other argument that has exactly the same form of reasoning. Okay, so here's a parallel argument. Most of my friends are organisms. Right? I mean, it's possible that a few of my friends are robots, but I think that's unlikely. I think at the very least, most of my friends are organisms. If one or two of them are automata who are cleverly disguised to look and act like human beings, so be it. Still, most of my friends, I'm confident, are organisms. Now, most organisms are microscopic. Of course, we don't always keep that in mind because most of the organisms that we interact with on a day-to-day basis are not microscopic. Human beings, dogs, cats, trees, right? These organisms are not microscopic. But in fact, most of the organisms that exist are microscopic. So, someone might infer, well, if most of my friends are organisms and most organisms are microscopic, then doesn't it follow that most of my friends are microscopic? Well, no, obviously not. In fact, none of my friends are microscopic. All of my friends are creatures that I can see without the use of a microscope. So this argument right here is obviously a fallacy. I mean, both of the premises are true, and the conclusion is certainly false. So this argument is obviously a fallacy. It's an invalid argument. But since this argument is invalid, and it has exactly the same form as this earlier argument about ignoring statistics of failure, it follows that this earlier argument must be invalid. Right? This earlier argument from the premises, most people who start businesses ignore statistics of failure, and most people who ignore statistics of failure are stupid, it does not follow that most people who start businesses are stupid. That doesn't follow at all. This is a fallacy. It's an invalid argument. Just showed that by means of parallel reasoning, by finding a parallel argument that has exactly the same form, but it's clearly a fallacy. So since this parallel argument is clearly a fallacy, this earlier argument about ignoring statistics of failure must also be a fallacy. Okay. Now, refutation by parallel reasoning doesn't always work. Sometimes we get results that are unclear or don't show what we were trying to show. For instance, let me give you an example of that. So consider the following argument. If guns are outlawed, only outlaws will have guns. That's premise 1. Premise 2, it would be bad if only outlaws had guns. Conclusion, therefore guns should not be outlawed. Okay, so that's an argument. It'll be familiar to some Americans. That's an argument. Is it a fallacy or not? Well, suppose we try to refute it by parallel reasoning as follows. If gum is outlawed, only outlaws will have gum. It would be bad if only outlaws had gum. Therefore, gum should not be outlawed. Now notice, this parallel argument has exactly the same form as this earlier argument about guns. The two arguments have the same form. So if one of them is a fallacy, then the other one is a fallacy. But is this argument a fallacy? That's not clear. It's not at all clear that it's a fallacy. So this attempt to refute our earlier argument by parallel reasoning doesn't succeed. It doesn't succeed because the parallel argument is not clearly a fallacy. So we can't tell by looking at the parallel argument whether the earlier argument about guns was a fallacy. So this is a case of refutation by parallel reasoning that doesn't succeed. So what's crucial in refutation by parallel reasoning is this. First of all, you have to make sure that the parallel argument that you're using to refute the original argument, that the parallel argument has exactly the same form as the original argument. And in all three of our examples that we've looked at, that is true. The parallel argument does have the same form as the original argument. But the second thing you need to make sure of is that the parallel argument is clearly a fallacy. Right? If you're trying to show that the original argument is a fallacy, and you're trying to show it by means of parallel reasoning, then the parallel argument that you pick has to clearly be a fallacy. Because otherwise, you haven't shown that the original argument is a fallacy. Okay? And this third example doesn't meet that second criterion. The parallel argument is not clearly a fallacy. Okay. So, that's refutation by parallel reasoning. Next time, we'll consider another way of refuting an argument. See you next time.